Yeah, it is my Halloween costume. It's not complete. It's not complete. Okay? It's not complete. But I'll show you. Good morning, everybody. Where did I go? What happened? Does anyone know? Does anyone have any ideas? The Unabomber? No. The guy from the news. Maybe I do know the guy. Yeah, don't say what he says. So, I'm gonna shave. But this is who I am. Is it a good costume? I think it is. You guys have never seen... I don't know. You guys have never seen that movie? That's who I am. It's pretty good, right? I'm going to have a purple hoodie. My purple hoodie's on the way, so... That's who I'm going. That's who I'm going as this weekend. That being said, it's a little bit too hot in here, so one moment. I just thought that we should share the Halloween spirit a little bit before the weekend comes. All right, so class has started. I'm gonna give a few I'm back. What do you know? I'm gonna give a few updates on just some things. Number one, completely unrelated to anything in this class. Patty got in a fight this morning. I let her out about 5:30 a.m. and she came back about 6. And she was in attack mode. And she kind of banged herself up a little bit, but I think she won. Long story short, I'm not sure if the other animal is in the house right now. Okay? So, I was doing office hours a little bit earlier, and I was hearing some banging going on, so I'm not sure if that animal is in my house. And if it is, I might have to stop the stream or, take a little intermission. But no, I think Patty did win. She had blood on her claws. And it was not her own blood, so I'm really not sure what happened. But I'm just letting you know that might happen. Now we can go on to the actual class. Now that that's out of the way, I thought I might take just a moment to go over one little thing from the assignment, but I'm going to take a vote. Okay? I'm going to kind of take a vote. So, some people are not really understanding the bracket operator. Is there anyone who's in that boat? I know there's a lot of you I've already talked to, but is there anyone currently in this class right now where the bracket operator, yeah, that's the one. You've looked at it and you're like, what the heck is that thing? All right, we've got one vote. I've got a 2 boat. We've got 2 people in the boat. Anybody else? We've got kinda here. Yeah, okay, so let's just take a few minutes to talk about it. Okay, let's just take a few minutes to talk about it. I think it's okay. I know a lot of people do know what's going on there, but I'll just take the moment to talk about it. So the idea is we have some matrix mat, right? And I don't know, it has some dimensions. And what I want for our matrix to be able to do is somewhere in main, I want to be able to say, hey, I'm not going to name it Matt. I'm going to name it M. I want to be able to say, hey, something like this. I want to be able to do that. Now, let me ask you, do we have this thing? Is this a real operator in C++? What do you guys think? Is that an actual operator that we have? No, it's not. Right? So this thing does not exist. So we only have, basically, we only have one option here, and that's to do this part. Okay? That's to do this part. And this part, we have to assume that it's going to perform like any other time we've done this, right? So for example, if you've got an int array equals new int, I don't know, 4, and then you say, I'm not even going to do the cout, I'm just going to say array at 3, this is like the same thing as dereferencing the array plus 3, right? So this here, this part is going to be doing just that, in that it's going to be dereferencing an address, all right? But we have the power to do this part. So that's what the bracket operator is doing. Now, if you look at the return type of this operator, it's a float pointer. Meaning that whatever it returns is probably going to be dereferenced. All right, so here's basically what happens. We're going to break this down here, and hopefully this will help us out. Yeah, so the memory that it returns will be contiguous. There will be elements that are side by side. All right, so this is kind of how it works. This is going to turn into something that looks like this, where the object calls the operator, bracket, and it passes 2 as the parameter. And whatever it returns will then be dereferenced at 2. Are you with me so far? This here becomes this, right? I've used this syntax before, so hopefully you're still with me here, right? That there's nothing, these 2 statements are equivalent, right? Now, whatever this returns has to be a float. All right, whatever this returns, it has to be a float. So, basically, what do you think this returns? I mean, there's some of you that know, so it's okay for you to answer. What does this return? In that, what is this part of our matrix supposed to be? What does this part reference? And in turn, what does this whole thing return? So it returns a float pointer. A pointer to what? A column, right? This part is the column, right? This part's a column. So this bracket here is referencing the x direction, right? It's the direction, but the index, the x index. And so this needs to return the column of that matrix. So in some sense, if that returns that column, I can sort of convert it to look something like this. Would you agree that this gets us the address of the second column in that matrix, right? Would you agree with that? this here would reference the second, or the third column, I'm sorry, the third column in our matrix. And let's suppose that this operator here returns that. And then we'll keep the same kind of syntax going on there. And then I can further simplify this to m.mat at 2. Now, in terms of what we were trying to accomplish, do you think the matrix at 2, right? Matrix 2, isn't this what we want? To be able to get the pointer dereferenced at 2 and then dereferenced again at 2. Does this make sense to you guys? For those of us who were confused, are we no longer confused? Right? This is going to return a pointer, and it's going to be dereferenced, right? So this will become something like, if you think about it, m.mat plus 2 dereferenced at 2, and then this further becomes star m.mat plus 2 plus 2. Still confused. So what are we still confused about? Still confused. All right. Here we have, we're going to do our memory. Okay? We're going to do our memory. So this is the mat pointer. Where's the mat pointer stored? It's at 060A. All right? And so that is probably in some memory along the lines that looks like this. Now, this is the address of the pointer, right? What do pointers store? They store other things. So this is storing an address to something else, right? This is storing an address to something else. What is that storing an address to? Well, it's storing an address to our matrix. So that might be 0x112 or something. Okay? I'll make these kind of red here. So now somewhere in here is 0x0 or 112, 0x112. All right, and this is, in terms of mat, what is this? If I wanted to access this, if I wanted to get this address out of mat, how do I do that? So what is this part here? So mat is storing this address, right? So do you agree that, yeah, mat 0, pretty much. Yeah, exactly. That's mat 0. Do you guys agree with that? That is the matrix pointer dereferenced at an address plus 0. Meaning that here we're going to have probably mat 1. Here we're going to probably have mat 2. Mat 3. Right? Because we're going to have allocated this. We're going to have to say equals new float, star, and then there's some value in here, right? Apparently Excel doesn't... hey. I guess I can't do this equal sign because Excel thinks I'm doing some formula or something. Right? So when we allocate something like this, we're going to get contiguous memory, right? In which we have mat 1, mat 2, mat 3, mat 4, all side by side. Meaning that this is probably 0x0 or 11, I don't know. How many bytes an address stores? Perhaps it's every 4. So that could be 0x11A. And then this is maybe 0x11F, something like that. Are you with me so far? And if you think about it, this is a pointer, right? So we might as well make that little pointer. It goes here. Whoop, right there, right? Do you agree with that? So mat has its own address, and it stores this address. When we dereference that address, we're down here, right? So when we say mat 0, we're here. We get this address. When we're at mat 1, we get this address. Mat 2, we get this address. mat3, we get this address. Now this is probably going to be, I'm just going to throw some random values in here. 0xb2f, 0x. These are just addresses from our memory. I don't know if they actually exist. 077. Now, unfortunately, in memory, it probably doesn't look like a matrix. Okay, it probably doesn't look like a matrix. Here's probably what it looks like. This could be 0x AAA. This could be, I don't know, this could be, it's my face. Oh, say goodbye, everybody. Woo, okay, here I am. This could be 0x1 or 0xb2f. All right. Then we could put this one over here. This could be there, and that could be up there. All right, that could be 0x077, and this could be 0x557. All right, and guess what? We've got some pointers, right? So where is this pointing to? This one goes up here. Are we having fun yet? This one goes here. This one goes here. And this one goes here. Does it look like a matrix? Kinda, right? If you want to bring them down here, right? If you kind of want to put them side by side, in that sense, they do become a matrix. It's just they are stored randomly all over the memory. You want the Excel sheet? I can do that. This is basically how it's stored in the memory. And if you want to imagine it, it looks like this. If you want to imagine it, this is our matrix, right? Now look at the columns. You see that? Look at the columns. Notice that they have addresses. So if we want to dereference this, this is, in some sense, this is mat 0, 0. This is mat 0, 1. Right? This is, say, mat 1, 2. This is mat 2, 3. And then, you know, this one is, say, mat 3, 0. So, and I could fill all of these in, right? You understand that. I could fill all of these in. So when I'm asking you in the bracket operator, I want you to return the column, the address to the column. So it's this, right? So basically, let's say I want you to return the address to the column at index 2. What do I type? Well, mat2, right? Quite literally. Quite literally, it's that. Yeah, no, the function is one line. If you want to be picky, make sure the index is inbounds. All right? If you want it to be more than one line, make sure the index is inbounds. Right? Make sure it's not negative. Make sure it's not greater than the width. The only reason it's like that is because it's a pointer. Well, yeah. Mat is a float. It's a float star mat, right? So when you dereference mat the first time, what do you get out of it? Well, you get a float pointer, right? And then what happens if you dereference it twice? You get a float. So I hope this makes sense. Sure, I'll share this after class. Do we understand? Is it okay if we continue on with today's class? Are there any further questions? Yeah, there's a lot of you who there's probably a lot of you who learned something about double pointers today, right? I should have done this to start. All right, so I've learned something today that I could definitely use this visual next time I teach this class. So, and I showed this to one of you in office hours already, so that's what gave me the idea. So whoever that was, thank you for the inspiration. So now we're going to move back to templates, all right? I guess that means I can return to normal size here. Okay. Okay. So, where were we last class? Well, let's take a look. Hopefully you've had a chance to sleep on it a little bit. Talking about templates here. All right, so what are templates? Well, it's a form of polymorphism, right? Has many forms. And there's a whole bunch of polymorphism that we've used already, all right? So we're kind of in the same boat here. Same boat, doing the same stuff. Nothing too different here, aside from that this is actually just templates, right? And then we need to know how to use templates. So what is a template? Well, it's a function or class. Today we're going to work with the class example that is specified to handle multiple data types, all right? So it's going to take some generic data type and it will fill it in for us, right? We've used templates before, that's a vector. And then I define what does it mean to be general. Well, we've talked about that before, all right? So I'm not going to review that. So let me see if I can resize this properly. I think it looks like that. So you can provide the function or class with whatever data type you want, and then the code you type will handle that case automatically, all right? So here we are talking about coding templates, and then we're going to add some additional notes here at the bottom. Now, as far as we got last class, we only talked about functions that have the template type in its name. Hold on one second here. All right. So we're talking about template functions that have the template type in its name. So we kind of looked at that last class. I'm going to shrink this down just a tidge. I think you should still be able to see it pretty good, especially if you're full screen. We did a sort, right? And notice here that the template type is appearing here in the parameter list. So what was I saying last class? Well, I was saying when we call print array or even sort, which are both template functions, how does it know what type we're working with? How does it know what type we're working with? Well, it knows because we are providing a variable. All right, we're providing a variable, and on some degree, the template will call, say, some operator like type ID of, say, the S array, and this will basically return, oh, this is a string array. Or, if you want to be more specific, a string pointer. Okay? And so the template will then go through here in its function. Let's look at this one. This one's a little more simple. Right? And it will replace everywhere it sees Deborah with a string pointer. So are we in agreement up to this point? All right. Obviously, you may need to review a little bit last class, but we're going to continue on today. But we covered this code pretty in detail, right? Last class. 1150 passed, everybody. Did you see that? 1150 has gone and passed, and I don't think I've frozen yet. I don't see any F's in the chat, so. Now we did talk, well, let's see here. If I use a template on a global function and I declare that function as a friend of a class, Pig, you are, wow. That question makes me happy. We will go over that today, okay? So that's going to be in our next example. That's a wonderful question, and I will actually cover exactly that in today. So, wonderful question. I'm glad that we had some chance to sleep on this. Chef says, do we have to specify anywhere what types the template can take? if I'm understanding that question properly, you cannot limit the types that this takes. Is that your question? You cannot limit, you can't like exclude types from this. All right, you can't do that. Yeah, it won't. This is a general. This is as general as you can get, meaning the moment you start excluding types, things start getting to be more specific, right? This is as general as it gets. So there's no excluding any types, right? And obviously, we kind of ran into some problems there with that, right? Because what happens if we pass a type to this function that doesn't have an operator for the less than sign, that doesn't have an operator for the assignment operator, or it doesn't have an operator for the insertion operator. I remembered it, guys. The insertion operator. Okay. So yeah, we kind of noticed that, right? We kind of noticed that. And so that's kind of the first thing I want to note. If your template function includes any operators, consider if those operators will be overloaded for the user-defined classes. All right, if your template function includes any operators, consider if those operators will be overloaded for the user-defined classes. So on the test, I'll kind of ask you this question. I'll say, hey, is this code guaranteed to work? And you'll say, nope, not in all cases, because right there we see the less than operator. And let's say we pass a chair to this function. I want you to sort a list of chairs, right? And it's going to say, well, that chair class doesn't have an operator for that. So it's going to break, pretty much. So as long as we understand that, we're good. Now we're going to move on to the next part. So if you remember here, there's two cases, right? We have case 1, the template type can be included in the parameters. Or case 2, the template type can appear somewhere in the body of the function. So what does that look like? So I'll include this here. And we're just going to kind of include this in with the same code. It won't fit very well, but we're going to try it anyway. So this is going to be our case 2 here. Template variable inside the body. It is not in the params. So what does that look like? Well, that will look like something void. Well, first we have to declare a template, right? So I could say template. Now we use this thing called type name. Type. All right, I could give it whatever name I want. And I'll say something like void foo. Now, what if I don't supply any parameters here? That's fine, right? That's fine. But somewhere in here, I'm going to say, hey, I've got my type temp, something like that. And you know, even if you wanted me to do this, we can return a value of that. So I think that might be a good example for you to see. Get default object. How's that? That'll be fun. So in your operator assignment, at times I ask you to return a default matrix, right? In which you're just going to type the call to the constructor like that. So what if I do a template for that? In which I just say, hey, type temp, which is called with the default constructor for whatever template type this is. So let's say I call this template type with a string. What default constructor is called? I just want to make sure you understand what I'm saying here. What am I saying here? If I call this function for strings, what default constructor is called? Right. Well, yeah, so Pig, you're right. If you wanted me to be a little more specific on this, I could say type temp is equal to type if you wanted to. Now, this isn't necessary. That's the same thing. That's the same thing as saying type temp. All right, that's the exact same thing. But let's say I've got a pointer to that element, right? Let's say I've got a pointer. I would have to say new type. Synthos asks, do we need multiple constructors to cover the cases? Well, I guess not in the question that I'm asking. And I should be a little more clear with this. What I want you to think about is, let's say I call this with strings. So just come in here and replace everything you see with a string. I can do this. Are you ready? It's time for advanced Visual Studio stuff. Boom. I've replaced everything in here with a string. That's not a bot. That's an old student of mine. Yeah, I'd love for you to be my TA someday. Yeah, she took my class a while ago. If you really want to be my TA, you'll have to send me a message on Discord, okay? Because I'm having class right now, but it's good to see you. So, back to this idea of initializing these, initializing template types to be some default value, all right? We're going to have to use, say, a type default constructor. And so all we have to do is use the default constructor on the template type. You kind of understand what I'm saying there? You would just call it like any other default constructor. This is the name of our type, right? This is the name of our type. And so how do we call the default constructor? Well, it's just the template type name with the empty parentheses, right? So that might be also another test question. I might ask you, let's say you have template. Let's see if you understand. Let's say I have a template type name Jimmy Neutron. So, oh, did we die? Bye, Cherry. It's good to see you. Thanks for coming. Okay, so I kind of hope we're back. So let's say I have a template type, say Jimmy Neutron. All right. And let's say I have a Jimmy Neutron pointer var, and I want to initialize this to have some default value. What constructor do I call? This is a goofy example, but I just want you to understand. I want to initialize this variable to have a default value for whatever template type we're working with. It's a Jimmy Neutron, so how am I going to initialize this? What do I type? A Jimmy Neutron, yeah, exactly. So that being said, do you think that we could ever use parameter constructors? Do you think that we could ever use parameter constructors in these template types? Yes or no? You think that we could use parameter constructors or special constructors? Exactly. No, you can't. All right? That's exactly right. You can't do that. It's as general as it can be. So you can initialize them with the default constructor. All right. So if you've got type name type, that is type. If you've got type name T, that is T. If you've got type name Jimmy Neutron, it's Jimmy Neutron. Now, types are always guaranteed to have a default constructor and a copy ctort. All right, you're always guaranteed those things. So in your templates, you can always use these. right? We know that if we don't include a copy constructor for our classes, the compiler will do it for us automatically. It will do it for us automatically. Mail, I'm sorry if that happens. I'll watch the connection here a little bit to make sure. All right. So now we're going to come back up to here, right? So we're working here with our case 2, in which we're working with something like this. All right. And guess this is kind of a fun function. It's going to return a default object of, say, that template type. But notice that it's not included in the parameters, all right? So let's say I'm down here and I wanted to say string s is equal to get default object. Now it's mad because it doesn't know what type it's using. Do you guys have an idea of how I could explicitly tell this function call what type I'm going to be using? What do you think? Obviously, it's not included in the parameter list here, right? So we're going to have to tell this function how we want to call it. And yeah, CentOS, you're right. Red line be gone. So, Chef, remember that this is a global function here. So it does not belong to any object. It does not belong to any object. This is a global function. So it can only be called like this. All right, CentOS and Cade were on top of it, right? Just like with vectors, if we want to reference this, and we haven't covered this part quite yet, but now we are. Just like with vectors, if we want to specify a type, we're going to include it here with these little carets, the less than greater than sign. Do you guys follow? Does it make sense? So then I could say, I don't know, matrix. I don't have my matrix here anyway. So I could say int I is equal to get default object for an integer. Obviously, this function's a little redundant, right? We already have a default constructor for a string, but just to show you that this will, we have to specify that type there. All right, so that's going to go in our notes here too. Case 2, if the template type is not in the param list, it must be the type we want must be specified in the brackets when we call the function. Okay? If the template type, the template function, well, yeah, the template type is not in the parameter list, the type we want must be specified in these little brackets here, not brackets, carets, when we call the function. So if we want to see just an example of that, it looks like foo type, and then whatever parameters are supplied, if there are any parameters that are supplied. Okay? So now we're going to move into classes. While we're at it, we're also going to use multiple template types. We're going to do 2 template types at once. So we're going to ask this question down here. Can we use multiple template types? The answer is yes, we can. All right, yes, we can. How do we do it? Well, the syntax for that would be in your template, you'll type template here, and then you'll list your type name, T1, type name T2, type name ... Okay? So we're going to do kind of a fun little class here. Now, this example that I'm about to type, I also asked this on tests, all right? I'll kind of ask you as a coding question. I'll say, hey, will you please make a struct that has multiple template types. All right, so this is going to be ct.cpp. All right. So on the test, I'll say, hey, I guess I don't need to do that. Please define a class or struct that uses multiple template types. Let's say we call this one a trio. Class trio. And so what does this trio do? Often this might be called a tuple, actually. You guys may or may not have heard that term before. All right, you may not have heard that term before, but you will. This will be often referred to as a tuple. So maybe we can do a tri-tuple. Okay. Big ask, is there a way to limit what types can access a template? I think Chef kind of asked this a little bit earlier. Templates are as general as they possibly can. You cannot exclude types from a template. If you wanted to do that, you would need to do it explicitly down here, where you say if the type ID of your var does not equal, say, matrix, or however that code works. I'll let you do that own research. Then you can say, I don't know, now I'm ready to use my template of whatever goes in here. Does that make sense? If you're going to try to exclude types from a template, you're going to have to do it manually somewhere else. You cannot specify on the definition of the template that, hey, keep matrices away from this. In some sense, the code won't compile already, right? I guarantee you, you want to see this? Check this out. Well, I'll keep this one here. But let's bring back the matrix class. What do you say? Let's bring back the matrix class. And let's say here I don't have this. Let's say I don't have this. All right, so here in my matrix class, I don't have this operator. I also don't have it here either. You see that? Now, we're going to run into an issue here. The less than operator is not overloaded. This operator, the insertion operator, is not overloaded either. So, if I try to call sort on this, I guarantee you things will not go well. Now, MoMA might hog my resources here. I didn't start it before class. So if I leave, I'm sorry. I didn't mean for it to happen. It looks like we're okay, though. All right, so we get this big, huge, disgusting error again, right? Look, I'll even zoom it out for you. How big is this error actually? That's how big this error is. Right, and if you zoom in on it over here, what does it say? Look, it'll tell you right here, if this, right? And what does it say? Well, it says no match for operator here. So, Pig, to answer your question, please tell me if it did. No, you cannot exclude types, but also your code will not compile if it doesn't work. So it's kind of a, I don't know if you call that a lose-win situation. The compiler not compiling is a way of excluding it, right? So back to this. Here we're going to do a tri-tuple. And so I want this tuple here to hold 3 different types, all right? I want to hold 3 different types. So just like I said, we're going to have, say, T1. You are welcome. Say we have T2, and let's say we have T3. All right? So here we have our kind of triple template. Now, we have access to these types inside of our class now, all right? We have access to them. So I could make some private variables. I could say T1 item 1. This is often how they're called. T2 item 2. T3 item 3. Okay? T3 item 3. And then we can do some stuff in here, all right? Now, there's kind of a few things we have to consider here. Let's say I am defining these constructors and these functions inside of this class. For example, we can make the try-tuple default constructor. And I might say item1 equals item1 or t1 t3 equals a default t3 and item2 equals a default t2. Something like that, right? Now, notice that the definition for this is included inside of the class, right? So when I ask you this question, how far does the scope of this extend? Can you tell me what line number the scope of these end? What's the line number that the scope of these template types end? $17, right? So notice that this definition is within the scope, right? This definition is within the scope. So we are allowed to say, hey, here's T1, here's T2, here's T3. They're defined, right? So I'm glad we understand that. So now I propose to you a different example. Let's say I want to make a parameter constructor in which we've got our try-tuple here. In this try-tuple, we'll take a parameter T1, a parameter T2, and a parameter T3. Now I'm going to say, hey, I want this definition to go outside. I want this to go outside of the class. So, guess what? I'll go, hey, try-tuple, need my scope resolution operator, try-tuple, T1, wait, I've ran into an issue here, right? Oh no. What's wrong? Can anyone tell me? Well, we know that the scope of those don't extend to this, they don't extend past this line, right? So what do we have to do? What do we have to do? Our class, it's broken. Is it broken though? What can we do? It's an easy fix. Just remember, well, so this is a constructor. It's not a global function. This here, it belongs to the class already. So we can't make it a friend. It's already part of the class. But Chef kind of gets the Chef kind of gets it on the second part here. We have to give it a template. This template is only going to line 19 at this point. We need another one. Now you can copy paste this here. That will fix it, but actually it's not completely fixed. Let's give these some different names. Type 1, because I don't want you to get confused. Type 2, type 3. All right. So now we've referenced here, or we've specified that this here is going to have its own template, or it's going to be using a template rather. All right. It's going to be using a template. Synthos asked, those are new T1, T2, and T3, right? Now remember that these templates, even if they had the same name, they're unassociated with this one up here. All right, this is kind of brand new. Now I have to specify specifically that this try-tuple is of these types. So similar, like a vector, I have to say that whatever object we have, it's going to be of these types. So some of you probably look at this and go, all right, from here on out, every time I have a template class, I'm just going to define everything inside of the function. Do you guys agree with that. But what's the takeaway from this here? Well, you can see that this parameter constructor is up here and it takes 3 template types. This is the same parameter constructor here. Now it looks disgusting, right? But it takes 3 template types. And the class object is going to be associated with those 3 template types. And they're passed in here. And so officially we have the definition for this. And we can say item 1 is equal to I1. We can say item 2 is equal to I2. And we can say item 3 is equal to I3. Now, why can we say that? Well, you say, what type is item 1? Well, you go look up here, right? It looks like item 1 is of the T1 type. All right? Now, what template is that associated with? It's the first one. It's the first one. So when we come down here, we say I1, what template type is that associated with? It's the first one. And we are filling in type 1 here as the first template for this tri-tuple. So therefore, item 1 is the same type as I1. Did I lose you, or does this make sense? I'm confused on why we reference the type 1, type 2, and type 3 are used to link the types. Well, I'll have to think on that a little bit. Is there a way that we could rephrase that question? She says, I'm confused on why we need to do the item I1. So think about it this way. Down here, we're going to declare some object of this class. All right? We're going to declare some object of this class. So it's going to be tri-tuple, say T1. I don't like using T1. We're just going to TPL. All right, and I can call this with some parameters. Now, the thing is, it's mad at me because this is a class, and we haven't supplied the type. So I'm going to say, hey, this is a string, this is an int, and this is a double. In which then I can call a parameter constructor that takes Patty, who is 5 years old, who weighs 10.6 pounds or something. All right? So these are the types that go in for this. All right? These are the types that go in for this. And so when we go up here to reference the class, this is a string, this is an int, and this is a double. Right? So this is a string, this is an int, this is a double. And so then we have a parameter constructor that we're calling that we want to fill in these values for. So basically this is Patty, this is 5, and this is 10.6. Now I didn't define this in here. If I defined it, it would be super easy. I could just say I1, I could just say I2, I could just say I3, and then I could copy this in here. Now look at this and this are the exact same thing. They are identical. The only difference is that this template that we've specified, its scope is for everything that's inside of these brackets. So when it references T1, it can reference this type name up here, T1. Now the issue happens when we decide that this is going to go outside of the class. The definition is going to go outside of the class. Excuse me. So when we put it outside of the class, notice that the original template scope ends. In which we say goodbye, T1, T2, and T3. Now we have to declare a new template. Now, Synthos asks, why can't we use that? The original ones work 100% allowed to. If I wanted to, I could say T1, I could say T2, and I could say T3. Because this is the beginning, this is kind of the header of a new template. And I could say T1, I could say T2, and I could say T3. The point being is that this template here is unassociated. I don't even know if that's a word. Maybe it's disassociated, or maybe it's just not associated. But this template and this template are different things. And how do we know that? Well, you can tell that the compiler knows that they're not the same thing, because if we don't include this bit, it will be mad at us. It will say, hey, this template, you know, it's a new template, and I don't know how you want me to organize it on the object. Do you want it to be T2, T1, T3, T1, T... You see how I can kind of reorganize them? And then look, it's mad here because the types don't line up. So Pig says, it's like declaring int I in a for loop. The variable ends at the end of the loop. That's exactly right. So just because we're declaring this outside of the class, we need to include a template again to say, hey, this parameter constructor is using a template. I also have to say that not only is it referencing the tri-tuple class, but it's referencing an object of the tri-tuple class that's in this orientation. Meaning that this template T1 goes there, this template T2 goes there, and this template T3 goes there. Then the parameters will take this form, and they will correspond to these items. And look, I assure you, if I make this a T2 here, well, it's already angry at us. So it's mad because there's no, it knows. It's kind of filling these in here. It says, all right, this is T2, meaning that T2 is the second template type of this class. It goes up here. This is T2. I don't see anything in here that looks like it has that header. If I wanted to make that work, I'd have to say that's T2. And now it will be able to line them up here. See, the red line goes away. So are we following? I know I kind of went on a little bit of a tangent there. I was just trying to kind of nail this into your head a little bit. That if we're going to declare this stuff outside of the class, we need to include a template for it. Because the scope ended. So I hope we're kind of all on the same page here. I know we're probably a little bit confused. But we really only have just a few more things to talk about. There's a lot of variables everywhere. That's correct. So now we're going to do I don't know if it's the most important part, but it may be the most confusing part. And this kind of goes back to a question that Hama asked on Tuesday. And it goes back to a question that I think Pig asked earlier this class. I can probably go find it, but yep. Before we do that, Chef asks, can we have classes that are templated and classes that are untemplated versions of the same class? Yeah. Yeah, I mean, you're going to have to give it a different name, right? You would have to be like, if I'm going to make a different class, it's going to have a different name. It's going to be, say, a tri-tuple string int float. And then in here, you don't have that template, and rather you just kind of grab this thing, put it in here, and you say, hey, this is going to be the string, this is going to be the int, and this will be the double or float or whatever I called it. Does that answer your question? Or was that your question? You could do that. They just can't have the same name. Actually, maybe they can. You want to try? No, it's mad. Argumentless. Yeah, it's mad. All right, so they have to have a different name. Okay, so kind of what I was just talking about here. Hama asked and Pig asked. We're going to talk about kind of, I don't know. This should answer your question. So let's say I want to overload an operator for this. Now, if we're going to do brackets, brackets are easy. All right, let's do the bracket. Well, no, bracket is not easy. The bracket is not easy at all. So we won't do that one. But we could do something like this. First, let's do some functions, some getters. We could do some getters here in which we say, hey, why don't we return, I don't know, get item 1. This could be a constant. Get item 2 and get item 3. All right. And what do these do? I don't know. They can just return those items. Pretty straightforward. My head kind of went a different place there. I wanted to do the bracket operator, but you cannot return multiple types from a function. I wanted to do a bracket where if I indexed it at 0, I'd return item 1. If I indexed it at 1, I'd return item 2. And if I indexed it at 2, I'd return item 3. But the operator cannot return multiple types. It will have to be one or the other. So instead, we'll just use some return types here instead. So just to explain that. Now let's do an actual operator overload that I wanted to do, and I want it to be the insertion operator. So what does that insertion operator look like? Well, let's do it out here first. I want this to be, say, an iStream. This will be operator. Goes like that, right? And then it takes some parameters, right? I guess I already provided them. We're going to have an iStream by reference that goes in. All right. And we're going to have a try tuple. Now we have an issue here. What's the issue? Can anyone tell me, and can anyone tell me how to fix it? What's our problem here? This is very important, and this will pop up on your next assignment. I will make you do an operator overload for something like this. And you're going to run into this issue here. What is the problem with this? We need to specify what template type it takes. Now I could do this, right? I could do this. String int double. But is this specific or is it general? Is this specific or is it general? Well, it's very specific, right? So if I wanted to, I could do a bunch of operator overloads. This one's for int double, right? This one's for int, right? Now we're getting into that League of Legends example I had before, right? If Malphite is attacking Annie, if Malphite is attacking, we're just going to have 20 million operator overloads, right? So instead, what do? Synthos says another type name. What do you think? I think so. Template. Type name. I like to use the T1, T2, T3 again. All right, I do. Remember, they're not associated, so they're different. It's a different template, all right? But I can reuse the names because there's no other template in the same scope that has those names. Now, how do we fix this? Well, the try tuple is going to have a type name here, T1. This will be the T2, and this will be the T3. Does that make sense? And if I wanted to, I would say, I did this wrong, didn't I? Why didn't you guys tell me? The extraction and the insertion operator obviously confuse me all the time. So I'm sorry about that. So if you were confused about that, unconfuse yourself. All right? Unconfuse yourself. And it's not going to be an in, it's going to be an out. Now, what do I want to do? I want to say out. Well, we're probably going to do, I want to make it look like a tuple. So we'll do that. And then we'll do tt.getItem1. But let's not do that one, because that's not fun. Let's actually just try to reference item 1. tt.item2. tt.item3. And our closing caret. And an end line. I made that a little vertical just so we could see it easier. All right. So here we are. Yes, Synthos, I agree with you. It is easier on the eyes to see it that way. I agree with you. And I would motivate you to do it, but at some times, and we're going to do it right now, you won't have a choice. You'll have to make them different. So we'll get into that in a second. Now, the first thing I want to mention is, obviously, I didn't do the get item 1, item 2, item 3 thing here, did I? I didn't do it that way. I actually tried to reference the private variables. Now, this is... these are private variables. So, is this operator going to have some issues? What do you think? Are they going to have some issues? I'm kind of suspecting that we might have some issues. What do you think the issue is? Or how do we fix it, right? We can fix it, right? How do we do it? We will make it a friend, right? We'll make it a friend. So let's do that. And this is where we run into the problem. So usually you'll just copy it. I'll copy it up to this point. I'll copy it up to this point. All right. So here I am. I've got my tri-tuple. It's going to be a friend. Now, here's where this is where the issue will come. I'm going to show you what the error happens, what the error is. So let's say I put this here. It looks okay, right? There's no red lines. Everything's fine, right? Everything's fine. Everything's okay. There's no red lines. Look, this template, it makes sense, right? That's going to go in for that. Let's take it to our compiler. I'm almost done with this assignment. I can't wait to turn it in. Oh man, Mr. P is going to be so proud of me. Oh my gosh. I can't wait. I just can't wait to turn this program in that's going to work. What is that? What is that? No. It was supposed to work. It didn't work. What is it trying to tell us? Well, friend declaration. Let's see. That's the insertion operator declares a non-template function. If this is not what you intended, make sure the function template has already been declared and add the carets after function name here. Well, yes, to answer your question, Chef, they have to have different names. Now, why is that? Well, notice this is where the global function or operator is declared. Notice that this template is not at all associated with this template. This template is not associated with this template. This is pretty much the header for this operator. All right? This operator is overloaded to work with all tri-tuples of any type, pretty much. And this here, this header actually doesn't match that operator. It doesn't match that operator. So guess what, folks? Template. Type name. Now, can we do this? Yes or no? Do you think that works? I've given it its own template. No? Yes? Well, let's try it. No, doesn't like it. It doesn't feel right. No, it doesn't. So Synthos, this is where you run out of luck here, right? You see that? It says here, it says it shadows. That's kind of a cool word. Declaration of template parameter T1 shadows template parameter. All right. So you're out of luck here. You're out of luck. So guess what? This has to be, I don't know, TP1, TP2, TP3, and then in here you're going to have to replace those. It's like Israel. No, that's like, oh, what's that UFC fighter's name? Masvidal. There we go, folks. We did it. Can we celebrate yet? Let's see. Did it work? Patty, 5, 10.6. So I do just kind of want to check in on this. Yeah, you can't even put it in the class. I'm sorry. You might be able to, but I wouldn't recommend. I'm sure you could get the code to compile at some point, but I would definitely recommend doing it this way. And so, Hamma, I don't know if this answered your question from last class, did it? Or something like, do you see that there's a template? There's a template in here. There's a template contained within a template, and they have to be different. And then Pig asked earlier, let's see, if I use a template on a global function and I declare the function as friend of the class, do I need to make the template a friend too? Well, I guess this kind of answers your question in that the template is actually a part of the header of this operator. So yes, you do have to declare a template. All right. So yeah, let me know if I didn't answer those questions. I hope that I did. We're gonna kind of throw in a few notes here, but we're pretty much done with templates. So think about some questions that you have while I'm filling in the additional notes here. And you can zone out if you want. If you think you understand what's going on, but if you don't, just listen to me here. I'm going to fill out these notes. And like I said, if you've got any questions, let me know. So, okay, Synthos asks, where does the TP1 template end? Well, that ends right here. Well, it ends right here because this is the header. So yeah, you're right. This is a little confusing. But this is just the header of that function or operator. It's the header of that operator. So it actually ends right here at the semicolon. If I were to do, say, another one, we can quickly do this. Let's do the other one. Boom, 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 boom. Return in. In item 1 and 2 and 3. Turn in. Okay. And then what do I need to do? I need to copy this and make it a friend. So pretty much I just come up here. I'm going to see if I can use this same template here. TP1, TP2, TP3. Operator in iStream, it's going to be a friend. And it's going to take TP1, TP2, TP3. Shall we try that? I did a little speed run there, didn't I? But we're going to confirm your question here, Synthos. Where does that template end? Well, it ends right where I said it did. Did I answer your question? It ends right there. See, I can use a template of the same type. They're kind of in the same level of scope. So, yeah, I hope that answered that question. Are templates considered unary operators, considering it acts on the function or class beneath it? I would not. I would just say no to that. It's not an operator. It's more you're just specifying that this thing can take many forms. If you want to think about it like that, you could. But the thing is, if you think back to the functions, right? If you think back to the functions in case 1, where template type is included in the parameters, you can just call a function with the same name. Or like, you don't have to specify the template type, right? Just like in that first example that we did. Here. Do you see here? It doesn't really look like it's being used as an operator here, right? Because it's not even included. So if I understood your question properly, I wouldn't consider it that way. So let's finish this up for classes. You always have to specify the template type when declaring the variable. All right, so that's just like vector type vec. Okay. So that's for classes. And that's pretty much that. Now, there's only one thing we need to talk about, or a few more. I'll kind of add them in here. This is not important, so I don't usually bring it up, but the keywords, type name, and class are interchangeable. I don't like it that way because it leaves room for ambiguity. I probably spelled that wrong. Maybe I didn't. But what do I mean by that? I mean that I can come in here and I can say, you know what? That's class. A type name and a class are the same thing, and it will work. I don't like it, okay. And in the assignment, I'll probably make it all type names. But if you ever see something like that, someone can put a class there, and it's just the same thing. Yeah, it's just the same thing. Maybe I'll include it in the example. It's the same thing. It'll compile to. The keywords are just interchangeable. All right? So don't be upset. You'll just have to remember that. Okay, you'll just have to remember that. They are interchangeable. Anything else? Type names follow the same name convention as variables. Template type names. What do I mean by that? Well, you can't put a number up front, right? You can't put a number up front. You probably can't give it the name of, like, you can't give it if, type name if. Why not? Because if is a statement in C++. So they follow the same naming convention that variables do. And then I mentioned that. And I kind of mentioned this. I'll just include it, right? I said any member functions and global operators. Any member functions and global operators defined outside of the class need its own template header as well. Any friend functions need the template header to accompany the friend statement within the class. And that's it. That's all we have for templates. And it's 12:45. We finished right on time. All right. So, I hope you learned something today. I hope templates aren't as scary as they were. Of course, we'll get some practice with those next week. All right. I'll have to get to you the test, the date test. All right. So I'll be working on that. Don't worry about it yet. All right. Of course, I'll provide that review for you, and we'll go over it next week. So put it out of your mind. Happy Halloween. I hope you guys have a wonderful weekend. If you're not going to go trick-or-treating, I hope, you dress up and and go out and whatever you guys do, guys and gals, whatever you do. The test date, all right? We'll go over that next class. I will be Damien from Mean Girls, okay? So, if you see me, be sure to say hi. Cade, you're welcome. Have a great weekend. Uchu, you're welcome. Chef, you're welcome. Have a great Halloween. Nicholas, you have a good one yourself. CS202 student, you are welcome. Emma, I am not the Unabomber, but you're welcome. Top Wolf, you're welcome. Fuzzy, I'll have a great rest of my day and weekend and Halloween. I do hope I find that animal too. I've got an axe here next to me just in case it's a bear. Centos, happy Halloween. You're welcome. YCS, you are welcome. Have a great day. See you later, Turbo. Have a great weekend. Yeah, I'm strapped. Patty's got my back. She does. All right, guys. I'll see you next weekend.